And then the other two pieces of information, little a represents the side opposite the angle. So if I'm given angle B, I would have side B. If I'm given angle C, I would have side C. And then in this case, B represents the other side. And that's always attached to the angle. So the reason I want you to think about this is because the diagram uses AB, side A, angle A, and B. But it's not always going to be side A, angle A, and side B. So those can change as you saw in that worksheet. Thinking about alpha really being angle A. These are the 4 different triangles that we created yesterday. Using the protractor and the roller, we actually created them. So there's a condition, which I had us write for each one of those, and then the possible triangles underneath. So for the first option, the condition is that A is less than H. The height actually controls a lot of the reason why a triangle exists or doesn't exist. So if A is less than H, you will never have a triangle. The height is too tall for that side to be able to connect with the base. The second condition is actually already labeled, and this is the second triangle we looked at yesterday. If they are the same, so A is the side opposite the angle. If that side and the height are the same, then we would have one right triangle. So anytime you calculate the height and you see that it's the same as the opposite side of the angle, then we will always have a right triangle. The third option was the third one that we looked at yesterday. And this happens when A is bigger than the height. So A has to at least be equal to the height or bigger for a triangle to exist. And then it's also larger than the other given side. So A is the side that's across from the angle. So if that side across from the angle is bigger than the height and bigger than the other side, then we will have one triangle. And then the last type is when we end up getting 2, and that's the special case that we're really going to look at today. That happens, again, when A is greater than H. So it must be equal to or greater than for a triangle to exist. But then it's less than the other side. That then makes 2 triangles. And we're going to talk about that today. So those are the 4 options that we have when our given angle is acute. And that's the angle that always goes on the left. So all of these diagrams that we draw, you'll have an angle on the left, a side also on the left, and then a side across. So we'll always know these 2, we'll never know the base. We're going to be finding the base. Questions? So those would be our 4 options if we have an acute angle. The other 2 options are when our angle is obtuse, which means it's going to be greater than 90 degrees. And in this case, the height we don't have to calculate because it's not inside the triangle. If I drew it, it would actually be outside of the triangle, and it doesn't affect whether there's a triangle or not. So the first condition, if A is less than or equal to B. So the side across from my given angle is less than or equal to the other side. There will never be a triangle. And we looked at that equal to case. So it has to be bigger because it has to be long enough to connect now that our angle is bigger. Other option is if it's greater than the other side, then we would just have one triangle. And that triangle is going to be obtuse because your angle is obtuse. one underneath, and then there are 3 on the next page. So I'd like you to just go through and determine on those 4 problems how many triangles exist. So you'll have to calculate the height, and then you'll have to compare. And the height's the most important part. That's what you have to compare first. How does the height compare to the side across from the angle? I don't want you to actually solve for anything. I just want you to determine how many triangles exist. And I mean, draw yourself a little diagram so you have kind of a picture shown. I think it says to do that as well. So determine how many triangles satisfy each of the following. Make a sketch. And then it does say solve for the missing parts, but we're not going to do that yet. So let's just decide like how many triangles exist based off of your given information. So all the problems for your homework tonight will all be this type of triangle. Every single one will be a side-side angle case. If it's not side-side angle, then you don't need to worry about doing any of this. It's just a regular old triangle, you use the law of sine, but it's the side-side angle that has that special conditions, actually 6 conditions, So you kind of have to think about what type of triangle you have and if a triangle exists or not. Only for side, side, angle. So none of the other options you have to worry about. Angle, side, angle, 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 side. So for letter A, have a little diagram drawn over here. And calculating the height, we would have 12 times the sine of 42 degrees. And Colin, what'd you get for that height?
I got 8.23.
8.23? Zero. So if we look at the side across from the angle, so that's side A, we want to compare it with the height first. So make that comparison first. So Colin, how does the side across from the angle A compare to H? A is bigger than H. So if it's bigger, then make a second comparison. How does A compare with the other side, which is B? A is also bigger than B. So if you have those two conditions, how many triangles do you have? One. And then we would solve for the triangle. We're not going to, but we would then use the law of sine to solve. So let's look into the next one, letter B. So calculating H, we would have 25, the other side, times the sine of 85 degrees. Reese, what did you get for the height here? 24.9. So again, before you do anything, compare your side that matches the angle with the height. Reese, how do they compare? Yeah. So the side across from the angle is 15. It's less than the height. So Reese, what does that mean if it's less than the height? There's no triangle. If there's not a triangle, you can't solve the problem. You're done. No triangle. There's not a triangle to solve for. If you did try and solve for it, you're going to get an error in one of those angles because it doesn't exist. There's an angle that's not going to exist up here. It's going to be that bottom angle because this can't connect to it. So really, this is what my triangle looks like. Side A is too short. It's only 15. It can't connect. So looking at the next one, looking at C, noticing the angle, Lauren, what kind of angle do we have? Yeah, this one's obtuse. So when your angle's obtuse, you don't need to calculate the height. We just need to compare the two sides. So the side across from the angle is A, the other side is B. Lauren, how do they compare? So what does that mean about the triangle? There is no triangle here either. So again, no work, no triangle. No triangle means no work. The last one, finding the height, because this angle here is 20.5 and that's not obtuse. So taking 31 times the sine of 20.5. Brenton, what did you get for the height of the last one? I got 10.5. So we would compare A with the height first. Brenton, how does A compare to the height? Greater than the height. So I at least have to have one triangle if it's greater than the height. And then Brenton, how does A compare with the other side that's given? So what does that mean about our triangle situation here? That means there's two. We're going to solve this one. This one's special. So we have now a situation where there's actually two. And yesterday we took that ruler and we spun the ruler inward and created a second triangle. It kind of looked like this. So I now have two triangles. I have the original one that I had drawn. I take this away. There's the original triangle. I'm going to draw it separately underneath. So here is the original triangle. 20.5, 12, and 31. So here's C, down there is B. So that's the original triangle. It's triangle number one. By rotating the ruler yesterday inward, we then got a secondary triangle. And that actual triangle is this little guy over here. We also have this one that happens to be in there, and that's just from drawing the first triangle, and then you have like now two triangles inside the big triangle. So I'm going to look at that little triangle on the side, and I'm going to draw it separately, except that's not very straight. That's better. So I'm looking still at the triangle that has angle A, because that's the angle they have in common. That's the angle that's creating these triangles. So here's 20.5. This is still side A, which is still 12, and this is still side B, which is 31. I'm going to call this C2, and I'm going to call this B2, because these angles are now different. But the other values are the same, because we still started with angle A, we still started with side A, and we started with side B. So we're going to talk about solving this one here, which is the original triangle that we all had when we drew these yesterday. And just kind of go over how to solve for parts of a triangle. So if you look at the one on the left, how would you start solving for that triangle? What would you do? So how would you set it up? Hannah?
I would first find the other side.
Yeah, we would need to get this other side C. And Hannah, how would you find that other side? Pythagorean theorem? Is it a right triangle? Oh, snap. Not a right triangle. All right, so maybe we can't find C first. It would be nice if we could. But what else could we find instead of finding C? You can find the angle, because we do know side B, angle B is across from it. So let's see if we can find that. So taking 12 and the sine of 20.5, because that's the matching pair that we're given. We're going to place that equal to 31 and the sine of B. So in your calculator, remember you need to use the inverse. We're taking 31 times the sine of 20.5. You're dividing that by 12. Plug that in your calculator. Use the inverse function, the second answer function. Get a value for the angle. $64.8? Yes. So 64.8. So now we can find C, angle C, because we know the bottom angle is 20.5 degrees. The other bottom angle is 64.8. Add them together, subtract it from 180, and the leftover is the entire angle at the top. Reese? 90. 94, is that what you said? 0.7? Okay, so now going back to what Hannah said, we have the angle across from C, so now we can find this base as well. Use the original pair, so we're going to go back and use that same pair. So we're taking 12 sine 20.5, and we're placing that equal to side C and the sine of 94.7. What'd you get? Oh. Anybody have it? Lauren, do you have it? 34.2. So questions with finding that information. That's how you use the wall signs. So start out with the given pair. The other side that you know, we need to find its matching angle. And then you can find the third angle and use that to find the side that's missing, which is the base. So if you go back up into the original diagram, because I have 3 diagrams here. Up here we have this angle of 64.8. That same angle down here is 64.8. The goal is for us to actually have information about 2 triangles, and I drew them separately down below as well. We need to be able to find the information in this little triangle down below. So we have to find this angle here, we have to find that little angle at the top, and we have to find the little base. And there's a little trick with this original picture that is going to enable us to find the other information. So if you look at this like secondary triangle that's created, the 2 sides are 12. If you have 2 sides that are the same, what type of triangle is that? Isosceles. If you have the sides the same, what do you know about the angles, Emma? The bottom 2 angles are the same. So if this angle here is 64.8, this other angle here is 64.8 as well. That's a property of an isosceles triangle. If the sides are the same, the base angles are the same. How can you use this angle to help you find that one? Which is what we need in this triangle. Emma? Subtract it from 180 because those are supplementary. It makes a flat angle. So if we have 180 and we're subtracting 64.8 from it, God bless you, then we get angle B, which is inside of this little triangle on the side. That's going to be obtuse. It's a larger triangle. And we get what? 115.2? So now we have 20.5. This is 115.2. We can find the one at the top by taking 180 minus 115.2 minus 20.5. That's going to be a smaller angle. And if you look, it does look like a tiny angle. So what's left after you subtract 180 from 115.2 and 20.5? Say it. Yes. 17.5? 62.5, sorry.
I got 44.
Yeah,
44 point what?
3.
3, okay. That looks a little better. That's already 44.3. So the last thing that we need to find is side C2, and I'm going to go through it really quickly. In order to find that, we need to take the initial side, 12 over the sine of 20.5. Place that equal to the little side over the sine of that angle that we just found, 44.3. So the 2 triangle case is a big problem. You're going to use that proportion 3 times. There's one of them in that group. And I think there are only 6 problems, maybe 7. It looks like 7 problems in the group of problems that you have to do tonight over the weekend. So one of them is going to be a big 2 triangle case. One of them definitely won't make a triangle at all. So have a great weekend.